Hi friends, welcome to follow up. Let's have a look at problem 2764. Is array a preorder of some binary tree? So basically we want to check in this problem if the given 2D array can be a preorder traversal of a binary tree. So in this video we are going to explain two solutions. The first one is verbose. We're going to build the tree or build the graph and then check if the given list represents a valid preorder traversal of the tree. And the second one, we're going to give a solution based on the use of stack abstract data type. Before we move forward, let's first look at the problem statement to digest the requirement. So here we are given a zero-indexed integer 2D array called nodes. So our task is to determine if the given array represents the preorder traversal of some binary tree. So here actually we need to understand that to determine if the given array can be a preorder traversal of some binary tree. So notice the wording here. So here the format of this list is the following. So each element nodes I is a length 2 array. So here ID is the node and the parent is its parent in the graph structure or the tree structure. So notice that for the root, so the parent ID is -1. So we want to return a boolean, right, if the given array can represent a preorder traversal of some binary tree, and false otherwise. So the node, it explains the preorder traversal, so which is actually a very common concept in computer science. So here we have two examples. If we look at the figures here, it's very easy to see if the corresponding nodes like 0, 1, 2, 3, 4 is a preorder traversal, right? So here 0, then we first visit this one and then visit 1. And for the right subtree, we're going to visit 2 and then 3 and 4. So we are going to have 0, 1, 2, 3, 4. So you check here 0, 1, 2, 3, 4. It is indeed a binary traversal. It's a preorder traversal. So for the second example, if you look at the picture and then let's look at the preorder traversal, we're going to have 0, 1, 3, 4, then 2, right? If you check this 0, 1, 2, 3, 4, it's not a preorder traversal of this tree or this binary tree. So now let's look at the additional assumptions or the constraints. First, the length of this list can be up to 10 to the power 5. So this is a decent large number. And this 1, this is the lower bound, it means that we're dealing with a meaningful problem, right? So here, the nodes element is a length 2 array. And this is the node value, node ID range in between 0 and 10 to the power 5. So this is the parent and ID range. So here there's a -1 because we want to distinguish with the root node. It should have parent's ID -1. So the input is generated such that nodes make a binary tree. So this is a consistency assumption, right? So with that said, basically let's look at the two solution formats or strategies. So here we are going to use two strategies to solve the problem. So the first one is we build the graph and do preorder traversal and then make a comparison. So this is very straightforward, right? So the second strategy what we're going to use is to use stack. The second way may be more efficient for this problem, but the first one is good for establish the intuition. So here let's look at the first strategy. First we are going to build the tree. So here tree is a special graph, right? And certainly we are building the graph. So here we can use adjacency list, right? So let's see the tree or graph. Let's use collections default dict. So we can use list or we can use set. Let's use list here, just because it's a binary tree. So this list has length at least 2 for each node. And then we're going to see for children and parents in nodes. Then we're going to do this tree the parents. So we're going to append, right? Append its child. So if you are using a set here, just change this append method to be add, right? So this way we build the graph. So let's call it step 0. So just for preparation, right? So next we're going to do the pre-order traversal, right? So for this, actually we can write a hyperfunction. Let's use a hyperfunction or utility function. So for this, I'm going to introduce a variable pre-order. So this is the result of pre-order traversal. Due to the format of this node, so I'm going to also return the node and parent pairs in the pre-order traversal. So this actually can be easily done. So we can use DFS, right? So the current node is parent, and then the traversal result. So notice that this guy, this list, is mutable. This is important for this for the writing format here. So first, we're going to append this pair, right? So the current and parent, and then we're going to check its neighbors. For neighbor in tree current, right? And then we're going to do traversal for neighbor and the current, and then this pre-order, right? And then for this problem, let's do the actual work. So we're going to do DFS. So we need first to find the root. The root actually corresponding to tree the -1. So -1 it must has 1 element. So this is the root, right? So then the parents for the root, and then the pre-order. So initially, actually, this is an empty list. So this way, we're going to have a list or array of the format like nodes. Then we want to compare if this is the case, right? So then comparison. So we're going to return. Let's give it. Let's see the final state of this pre-order. Let's see if they're the same. So this way of solving this problem is sort of straightforward. So here again, I want to emphasize. So we want to check if the given nodes can represent a pre-order traversal of a binary tree. So now let's look at the example. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. So now let's move to another solution format, the second one. So actually, for the tree, if we do traversals, so for example, giving you a tree, and then you are required to do pre-order traversal, so you can write in iterative format or recursion format. So that's actually from the giving the tree to the pre-order list. Now we are given a pre-order list. We want to check if we can this list can represent a pre-order traversal of binary tree, because the node have already given the parent and the node parent relations. We can directly do this, right? Sort of like reverse, but not exactly. Now let's copy the this signature here. So now I'm going to regard this one as solution V1. So hopefully this solution V1 have already helped you establish the intuition. Now for the second one, so it's much clean, I would say. First, I'm going to get the length. So this is just for convenience. And then we're going to check. So for a tree, valid binary tree, we want the node should start from the root of the tree. So in other words, let's check if node 0, the first node parent pair, if the second one. In other words, if this parent is -1. If it's not -1, it means that the first pair is in the first element is not the start or not the root of the binary tree. It's for sure not a pre-order traversal. In this case, we're going to return false. And then this is actually an edge case, right? So pre-order traversal should start from the root. And then we want to use the stack and abstracted type. So here the merit is that, so for visiting a node, for example, current node, then its parent should be already visited, right? So here let's use a stack. So now, because we have already finished the if block, so we can use this one. So here it stores the node and parent, right? So notice that the first one is a node and the second one is the parent. So now we're going to iterate. So for I in range, so we start from 1 up to n-1. So we want to check if currently we are visiting nodes I. So let's see, visiting nodes I, this pair. We want to see the corresponding parents has already visited. So basically we want to check if, let's see, it's a val block. It's a very typical pattern, right? Well, S is not empty and S -1, so the top element. Then the first element is a node. We want to check if this guy is the parent, right? So if it's not the parent, nodes I, the parent should be at index 1, right? If this is not the case, so we're going to do pop operation. So until we can find this condition, this equality chain holds, right? So after this after we exit this val block, there are two possibilities. One is that S is empty, or S is not empty, but the equality holds, right? So if not S, it means that S is empty. It means that for the current node represented by node I, in other words, the first element in node I. So it means that its parents hasn't visited yet. So this actually gives us a false, because it's impossible, right? Because we should have visited its parents when we look at the nodes in the pre-order traversal. So otherwise, so S is not empty, but this one. Now, at the current state of the stack, the top element indeed represents the parents of the current node, and that's good. So then we're going to append this nodes I. So here we are appending the pair, right? The node information and its parent information in order to continue this check. So afterwards, if we finish the if for block, for loop, and nothing returned, so we're going to return true. So this is the second solution format. So now let's do a test again. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. So this is the second solution format. I guess for this problem, that's about it. So here, before we end this video, we want to emphasize the understanding of the problem statement. So here we understand the task is to determine if the given array can represent the pre-order traversal of some binary tree. So with that said, I guess that's it for this problem. So you are welcome to modify the code and come up with other solutions. Thank you.